dynamic variables, time, and EQ frequency automation. To optimize performance and manage costs, the number of ambient bed layers was limited to 2 or 3, which required an effective method for customizing them. One approach was to use an LFO on the frequency bands to modulate the frequency sweep rate, combined with the randomizer to generate varied LFO values. However, there was a limitation Wwise. The new LFO values could only be applied when the sound was retriggered, which was not ideal for long ambient beds. To overcome this, a custom C# script was developed to simulate LFO oscillation for low, medium, and high EQ frequencies. The script allowed the frequency sweep rate to be updated dynamically based on the time elapsed since the last game frame. To enhance unpredictability, the method only executes when one of the frequency values reaches the minimum or maximum range, with the range itself fluctuating. The elapsed time since last change float is also influenced by a variable called increase time. This variable is activated when the player is moving and adjusts based on the player's movement state, like walking or running, providing a more interactive experience. Additionally, the increase time variable controls the wet signal for tremolo and flange effects on the TUD ambience bus, as well as the player's breath sounds. Elevation and distance. Elevation and distance variables were also utilized to make the ambience even more dynamic. The idea to incorporate these parameters was inspired by Lewis Thompson's blog on designing ambience systems in Wwise. In a separate script, the elevation is calculated based on the difference in the y-axis between the ground floor and the player's position. The elevation difference is then normalized between 0 and 1 in relation to the total elevation range of the game map, which is defined in the class level. The filter float uses normalized elevation difference to scale our future RTPC value. With the initial RTPC value set to 50, the elevation difference determines whether the player is below or above ground level, ensuring the RTPC adjusts accordingly. The resulting filter value is bound to the RTPC, which is used to slightly adjust the pitch for 2D and 3D ambiences inside Wwise. For my ambience design, I also wanted to maintain a consistent room tone across different areas to ensure sonic coherence, while keeping the environment dynamic. To achieve this, I created a new noisy room tone, where the output volume and filtering vary depends on the player's distance from the nearest game object tagged as window, which also includes certain wall objects.